The word mathematics means exact knowledge.
Vladimir Arnold majored in mechanics and mathematics at Moscow State University in the 1950s. In 1954, his mentor, Andrei Kolmogorov, outlined the KAM theorem, subsequently proved by Arnold and Jürgen Moser. It involved the stability of dynamical systems, such as two planets orbiting the Sun. They would interact and perturb the orbits. Theorems have been produced on this three-body problem.
The fact that forever the planets would not fall with each other, collide, and so on. But it's very difficult to prove. KAM theory is the first attack to this problem for 3 centuries, continued by thousands of different people in different domains, in mathematics, space research, celestial mechanics, astronomy, physics, thermonuclear reaction, magnetic field theory.
One example are the reflections from charged particles trapped in the strong polar magnetic fields, known as aurora borealis and aurora australis.
The question is, how long would it remain there? It's very similar to the thermonuclear problem. The KAM theory is providing also the solution of this, but I have done independent progress in an independent problem.
Take this huge TV antenna in Moscow.
You have a net of metallic rods. You start from a point and you go upstairs along one of those system of lines. But then you descend the point A to the point B. If there is a resonance, then there might be a perturbation along this line. The measurements show that when there is a resonance, it is unstable. And the same technology used to study the three-body problem can be also used to study the stability of those things.
Arnold remembers mentor Kolmogorov for more than his maths. Students in Soviet times had their stipends rescinded for offending the Communist Party.
Kolmogorov told to this student, don't be afraid. I have a lot of money. I have paid you for my pocket 2 times more. And he has done it. His principle, the talent should be pardoned. I was pardoned every year, all the time. It was wonderful.
Arnold got his PhD and taught at Moscow State. At 18, still an undergrad, Arnold wrote a letter to the Soviet physicist and Nobel laureate Lev Landau.
I have read 10 volumes of your theoretical physics. I have discovered 199 mistakes, and he agreed with all of them.
The mistakes Arnold found were eventually corrected in the American edition of Landau's volumes.
I am maybe the last universal mathematician who is working in hundreds of different domains.
One celebrated Arnold conjecture is based on the work of French mathematician Henri Poincaré.
Consider a circular ring. Every point of A is sent to a new point. The conjecture of Poincaré. F preserves areas. Second condition. F rotates the boundary, which has 2 parts, oppositely. Poincaré conjecture. F has at least 2 fixed points.
Under these 2 conditions,
This science is called symplectic topology today. What I have done, I have extended it. For instance, I have considered the case of a torus surface. There is no boundary. However, I have invented the condition representing it. It's called exact mapping. They are not conjecture. It's not for the 2-dimensional torus. It's for any manifold, any surface of any dimension.
Since 1986, Arnold has been with the Steklov Institute of Mathematics. His current work involves the mathematical theory of randomness.
The geometrical progressions are hundreds of times more random than the arithmetical progressions. So this problem, being random, not have random origin, neither the first nor the second. Somewhere, this problem of randomness is always presented.
Arnold lives in an apartment a few minutes' walk from the Maths Institute.
Here we are.
Do you play the piano?
No, I'm not playing, but my grandchildren are playing. I'm very old. I have grandchildren. Like that already.
Arnold is 71.
That's my father. He was a mathematician. This is my first mathematical work. I was 8 years old when I made this.
Several generations of Arnold's family have been scientists.
In the family, they told that my first mathematical discovery was made when I was 4 years old.
It was during the war. The family had a flat in Moscow in which the floor was very uneven. His father tried to place a stool, but it wouldn't stay.
And then I observed him, and I commented that you have moved the chair, turning it by a right angle already. And it never stayed on floor. This proves that the chair is wrong too.
Father then sawed the stool legs evenly.
My common life is like that.
Spent in the wild, swimming across rivers, skiing in the Alps.
For some 50 miles, bicycling, collecting mushrooms.
That's when mathematics came to him.
In places like that, sitting or even lying in the grass. I'm writing about 50 pages a day of mathematical calculations. It's a lot. My wife is displeased by that because she has not enough money to buy the paper. But that's her, my wife.
Eleonora is a medical doctor. How did you two meet?
That's a result of a bicycling accident in the forest near the Moscow River. We married several years later.
You understand Vladimir's work, the maths?
No. She's honest. She would not pretend to understand it.
Is there something you want to do before you stop working?
I never stop. I have no plans to stop. No.
St. Petersburg, Russia. Native son, Professor Ludwig Fadeev, attended and taught at Leningrad, now St. Petersburg, State University.
All my family were at university.
Notably, his father, Dmitrievich Fadeev, was professor of mathematics.
I think that among young people there is feeling of independence, and so I really wanted to do what I can do myself.
So Ludwig chose physics instead.
This small red building says birthplace of theoretical physics in St. Petersburg, in Leningrad. 50 years ago, it was almost unknown.
Ludwig himself blazed trails in the early 1960s with his doctoral thesis in physical and mathematical sciences. It was related to the scattering theory of particles.
In the case of three particles, they could come on each other, scatter, collide, go back to infinity. So information about all possible processes in this system are included in what's called three-body problem.
It was a problem which stay in front of theoretical physicists, say, 30, 40 years.
Peter Kulish is a protege of Fadeev.
It was quite tricky to prove that now these equations are ready to be used.
In Fadeev's equations, the T matrix for the scattering, K and P for the momentum of three particles.
My contribution was in understanding that this particular operator must be taken as a sum of three different ones, which corresponds to three possible channels. At that time, nuclear physics was very much on the top. And so my paper was immediately used for practical calculations for nuclear reactors. I have about 200 published papers in journals and books. And
It's said all computer calculations needed for application today use Fadeev's equations.
my doctor thesis gave me really international acknowledgement. But young Mills gave me more fame, so to say.
In the mid-50s, Yang Qinming and Robert Mills proposed a quantum field theory to resolve some confusion in particle physics.
Young Mills field itself was vector field, but also a matrix which acts on this. So it's many-dimensional object. But what are the particles, what are excitations which correspond to this field? I decided not to pay attention too much to physical applications first, but to understand how to work with them.
Ludwig worked with colleague Victor Popov. Their finding in 1967 introduced additional fields, later called Fadeev-Popov ghosts.
We were to add to it also action of some fictitious fields, which in physical processes didn't enter, but in the calculation very, very important. And so that's why they were called ghosts.
Fadeev and Popov's findings contributed to the work of Hooft and Feltman, winners of the 1999 Nobel Prize for Physics.
You should have gotten the Nobel Prize.
Well, these things are usually not discussed.
Fadeev has garnered many international awards.
So sure, I am proud.
Now a director of the Euler International Mathematical Institute, Fadeev in the 1970s was a pioneer in recognizing the importance of newly discovered solutions of non-linear partial differential equations, or solitons.
Models for which solitons were treated, we have only one space and one time, nothing else.
It took Fadeev a decade to devise a full quantum theory of multi-dimensional solitons.
In the course of this quantization, we found very important general structure, which somehow underlines all possibility of exact integrability of these equations. And this structure we called Young-Baxter equation. It led also to new mathematical structure, which is called now quantum group. It's very satisfactory when such things happen.
Nowadays, working mostly in their dacha, Fadeev, aged 74, continues work in the Yang-Mills field.
Understand what are particles which correspond to Yang-Mills field.
What is it about maths that attracts you?
It's quite attractive to have play of mind somehow. It gives you also quite internal freedom. But the main thing is there are many questions which are not answered yet. And the quest is to try to find the answer. My father told me long ago that he thinks that he was sleeping. I didn't believe him, but now I know that it's also possible.
Father was a world pioneer of homological algebra and a professional pianist. His mother, also a mathematician, named her son Ludwig for a purpose.
The reason was that my mother's dream was that her son will be conductor.
But he's always thinking of maths?
Maybe not. No. We have
No. He's considered a normal man, actually. He can help me, he can cook.
Ludwig and wife Anna, a physicist, met at Leningrad University.
And sometime on the 4th year, I think, we decided to go hiking in Crimea.
I invited him.
We became somehow more closer. After 2 years, we married, yes. Well, at that time was no necessity to, to officially marry, but when she began to expect a daughter, then we decided that she must have father.
So you gave up your career as physicist? But I decided to
Her mother was...
stay a woman. So how would you want your work to benefit mankind, ultimately?
I continue the general human tradition of making new knowledge. Skill will come with knowledge, but knowledge will not come with skills.